Hello, friends. I'm Ashish Darbari, founder and CEO of Axiomise. To our new listeners, welcome. To our old ones, welcome back. Happy New Year. We are in 2021. So let's hope that we are embarking on this with a fresh perspective, with new energy. And I've got somebody very exciting today in house to give us a boost. We have none other than the CEO of RISC-V International, Calista Redmond. Hello, Calista. Welcome.
Hi, hello, great to be here. Thanks so much for inviting me.
Oh, you're welcome, and thanks for taking time out. And especially, this is our very first podcast this year. So, hey, I have been following the RISC-V story for some time, and I remember meeting you in 2019 when the world was still quite normal. Talked to you and heard your talks, and a lot of us know you, or at least we think we know you. Um, but if you don't mind, Callista, can we get to know you a little better? Where were you born?
I was born in Minnesota and so grew up in the Midwest and proceeded from there to Chicago, then Washington, D.C., then New York City, and back to D.C. again. So it's been a little bit of a geographic journey up until then, but I've been here now for somewhere around 20 years.
Very nice. And how did you end up running the RISC-V Foundation? I mean, how did you actually wander into science and high tech? Actually, that is something that intrigues me when I talk to people.
Yes, absolutely. So, my personal journey, I ended up at IBM for about 12 and a half years. And through my experiences there, I was working on so many different relationships between companies. I was always in the hardware part of IBM, ranging across all of their brands, systems, and technologies. And, throughout my experience there, whether it was with mergers and acquisitions or divestitures or large scale alliances with any flavor of different ecosystem partners, I came to really focus on where we can level the playing field and allow maximum participation from entrepreneurs to multinationals. And, open source is really the force of change in technology and where you find a lot of synergy and positive energy amongst all sizes, shapes, and interests. So that's what led me to open source. What led me specifically to RISC-V International was the great opportunity that had been unmet through proprietary architectures and sort of the groundswell movement that had started with so many different forces at play that made this the right time and right place and right technology to embark on sort of that level of collaboration.
So basically, soon after you left IBM, you joined the RISC-V Foundation. Is that right?
Yeah, I basically went out one door into the other.
Oh, wow. Awesome. And at IBM, you were mostly dealing with business side of technology? Or
Yes, exactly.
I see.
I am not the one that you want hands-on code.
Oh no, that's always useful, right? I mean, I'm running this company, and I fully value and appreciate the business side and why we need experts like yourself. So,
Yeah,
Calista, yeah, sorry.
when you think about technology decisions, it's never because technology is cool and you can improve performance or any other dimension at the tech level. You also always have to have that business case. You can't go
Absolutely.
to the boss and say, "Hey, this is the coolest thing ever." The boss is going to turn around to you and say, "All right, show me the money,
Yeah,
right? Where am I going to save money? Where am I going to have expanded opportunity?" And so those dimensions are critical for any technical decision.
so this is a very interesting point you made, and I wanted to ask you another question, but I just want to pick you on this one. So, coming from a corporate world, the mammoth IBM, driven by profit and loss and the commercial interest, you're suddenly now driving completely opposite ecosystem with a completely different focus, which is, of course, on business and growing other businesses. But it's the view is certainly not so much on P&L, but mostly on driving a change in the way the world moves on. So it's a very different path. How did you?
It's it's a It's different, but it's a very close cousin, or maybe even a sibling. It could be a twin, right? I mean, open source has been a key element of IBM's strategy for decades, right? They were one of the first huge proponents of Linux and really helped to underwrite an entire movement. And their commitment to open source is not just self-interest, although, being able to interoperate with other pieces of the ecosystem more transparently is absolutely critical to any business. And that's where, long ago, nearly a century ago, we started cultivating standards, open global standards that everyone could ascribe to and attach a technology to. And it's no different, really, when you start to tackle things like open source software or open standards and standard specifications like we are in RISC-V. So it is actually a critical piece of strategy to be able to collaborate closely with your innovation partners, with your supply chain, and then to expand your market opportunity as well.
Yeah, very interesting. Very interesting perspective. So let's talk about RISC-V. So we know RISC-V is the fifth generation of the architecture, and for those of us who've been around for longer, it seems that it's always been around, thanks to David Patterson. But what exactly happened in the last decade to spur this massive movement into open source ISA? I remember in my days at ARM, we were living in this world that ARM would be the architecture for the digital world, and this is where the corporate messaging was going. That was a decade ago. And it looks like in this last decade, especially in the last few years, I think this whole movement towards open source ISA has picked up massively. What do you think is the main reason behind it?
Well, so if you go to its roots, RISC-V was cultivated at Berkeley with the intention to enable universities and students to be able to design from the ISA to tape out. And, while that aspiration was, noble, it soon caught the commercial interest as well, because there was that level of transparency that was basically unheard of in the proprietary space. You would get to a point where, you would encounter the black box. But, the influence that has driven this to broader commercial adoption is really around the business side. It's around opportunity. And that opportunity has been exploding. I mean, you think about it now, you could have a microprocessor in your toothbrush, in your car, a dozen of them in your phone. And the ability to maximize and optimize those design points based on an open architecture, and one that is small and very modular, has really spurred interest in RISC-V. If you look at most of the architectures out there, one example is 1,500 instructions in the base ISA. RISC-V has 47, and the reason that we got to this point historically is that those traditional, architectures were built incrementally. You kept adding on and piling on as you encountered new workloads. And RISC-V takes a modular approach where the base is frozen, and then you add on those extensions that are relevant to your workload. So at a business model, the dynamics have changed. The base equation has changed. It used to be price and performance. And the third variable now that has come into play is really design flexibility. And that's something that you can achieve while ensuring that you have maximum security and transparency through the entire code stack that has really spurred this moment. But when, the business side of it purely is around that opportunity. You see an explosion in IoT and industrial and embedded in AI and ML, name your buzzword, and there's a custom processor opportunity.
That's right. And in fact, you nailed it. I think there is a business side of things which initially gave it a spur, but actually the architectural simplicity is astounding, especially if you look at the other architectures in the industry. And I think most of us who did, starting with Motorola architectures and then the Intel architectures and then going to the ARM, So I can see that this combination of driving it for business reasons, but keeping it simple and extensible, and being able to allow everybody to contribute to create a transparent system, basically, for making sure that modern verification concerns such as safety and security are addressed properly. So yeah, thank you. Thanks for clarifying this. It was useful. Sometimes you think you know why things are happening, but you don't really until we have a chat like this. So, sometimes you need a revolution to drive major changes. And I clearly think RISC-V is a revolution. And they are often a force for good. And, I'm also quite a big believer of philosophy of science, and I've read a lot of Kuhn's work in Harvard Philosopher. And, sometimes you really need to rock the world. I wouldn't want to say this, but last year, 2019, was rocked in the bad way, you could argue. But at the same time, science pulled along, and the way science has moved in the last year, I don't think science ever collaborated that way. But, anytime we move too fast, there's always this danger of, running too fast before you've actually learned how to walk. So, with this rapid growth of RISC-V, and especially the distributed nature of it, what do you perceive are the challenges for further growth and adoption?
First, on your first point of revolution, so if you take the philosophy, whether it's for technology or economics or politics or anything at a philosophical level, when the world is faced, now I'm going to go big here, the world is faced with a profound challenge. That challenge could be the pandemic of 2020. It could be, economic turmoil. It could be a climate catastrophe. Could be at a local or regional level, forest fires or, a famine. When the world faces any of these challenges, they don't overcome them by taking isolated approaches. You overcome challenges throughout history, even in war, right? You overcome these challenges by coming together, not coming apart.
Absolutely.
You come together on a mission that is clear and meaningful for everyone. And, so you take your village and you bring all of your experts from around the table, your doctors, your grocers, your farmers, and you bring that ecosystem or that village together to overcome those challenges. For RISC-V in particular, you could look back in time to processor wars of the 80s, right? So many independent approaches trying to take proprietary position in those architecture wars. And that settled out, and Intel, sort of took hold on the servers and desktop space. One thing those have in common is they have a plug in the wall, a constant supply of energy. So the next revolution really came, a decade or two later, when we started having things running off batteries, hopefully rechargeable batteries, and, the advent of cell phones, tablets, laptops, other things that were disconnected from that constant energy supply. Now, you still needed the massive volumes to achieve some level of economic durable strategy, as you did with the prior kind of technical advances. And that's where ARM really kind of came into the picture, right? They were able to tackle those technology challenges with, a unique approach, which started to look like some level of collaboration.
Yeah.
Right. And now, our current era of computing, those design points are getting smaller. The constraints are around energy, or, if you're going into security and stoplights and or automotive, where we have autonomous vehicles that you're hopeful won't run over the cat or the elderly crossing the sidewalk. All kinds of different dimensions where processing is needed, and we needed a new approach. And that's where, you see things like RISC-V coalescing around a shared interest to progress the state of the art while tackling, the next wave of technology challenges. And that, that third point in the equation of design flexibility really starts to come to bear. So, to kind of go back to, how will this continue to provide and persist strategically for many different companies?
Yep.
You don't see the same pressure of economics and volume because we've lowered the barriers to entry.
Right.
You can
That's
now
right.
get to a custom processor with hundreds less developers and engineers, with millions less in development expense. So you no longer need to meet the volume requirements in order to close your business case. And that allows for far more custom processors to go into far more types of implementation. And you have reusable pieces and parts that you can draw from, which in turn will accelerate your development time frame. It reduces your development costs. It reduces your time to market. It allows for expansion into other adjacent spaces. You can take what you're doing in your wearables and bring them into other types of implementations. And that's why, things like RISC-V are really taking root, not only with the multinationals. You see Google, NVIDIA, Western Digital, Seagate, and others really investing deeply in RISC-V, but you've also got the playing field wide open for entrepreneurs. Today, we have more than 100 companies who have adopted RISC-V as their core strategy.
Right.
And so there's a distinction there, right? The large multinationals have massive sunk investments in existing architectures.
Yep.
But they have a full foot in the water with RISC-V as they look to, streamline their development, operate more readily together with their partners, and whether those are innovation partners or supply chain, and to be able to leverage those, kind of reusable pieces and parts to achieve a greater flexibility in existing processors or existing products and other pieces of their portfolio. And you see that in microcontrollers, whereby you have entrepreneurs leaping into RISC-V and investing in that as their main play. And you see that in IoT and embedded. That's where it's kicking off. And then you see other pressures in the system, and we'll just call those geopolitical, where you have entire regions and countries who want to achieve some level of technical sovereignty, but still participate in a global landscape.
Yeah.
And so you see the European Processor Initiative looking to leverage more open source and leveraging RISC-V specifically in acceleration. You see nations like China and India investing deeply in RISC-V. India in particular with the Shakti project has inspired an entire generation to adopt RISC-V, from the university level to entrepreneurs and others that we see coming to market pretty rapidly.
So what I noticed is that you've actually turned my question on its head. So I actually asked you for challenges for growth and adoption, and what you're actually telling me are all the reasons why you see less challenges but more opportunities effectively.
Right.
And that's what you're saying. I mean, of course, anything we do will come with its own challenges, but you're not actually seeing anything too obvious as a blocker at this point. Am I right in saying that?
There are challenges to growing any business.
That's
and
right.
If you want to point specifically to RISC-V, we don't have the same decades of experience in cultivating that ecosystem to the depth that the existing architectures have. So, the most obvious area is that RISC-V is moving so rapidly that the ecosystem is running to catch up.
Yes.
And that ecosystem is like full tilt running to catch up.
Yes.
And we see lots more VC investment. We see lots more existing, folks investing in RISC-V for all the dimensions that we need, whether it's at the operating system, whether it's around verification, whether it's around, all the other pieces. And many of those we are pulling into the RISC-V community so that we don't continue to develop independent or isolated solutions, but rather collaborate on the best that we can to serve the broadest set of stakeholders. So
that's a fair
where
point.
there are missing pieces and parts to the ecosystem, those are the ones that are coming together even more rapidly. So we've seen, 100% increase. We've doubled the number of technical work groups over the last year. We've seen, triple the number of folks engaging in our work groups to do those common deliverables that we all need. If it's something that we all need, then why do it yourself?
I would like to play devil's advocate, and I'd say, I hope we don't have too many cooks now. But I think we'll end up finding out who cooks what and what kind of meal is actually delicious. So that's the fun of growing things together. So what's next? So we've got RISC-V. I know there's a lot of work going on in Open Networking Foundation. Do you think GPUs are next? Do you think that might be also where people are craving to go, and there would be probably open source GPU architectures and vendors trying to make things? Okay.
We're seeing a lot of intersect from HPC over to scale-out cloud, and those are all about tackling new workloads or better serving existing workloads. And those challenges are often around acceleration. We see a lot of competitive interest in cloud providers around AI or ML. And those particular types of workloads are where we're seeing a very strong interest and growing interest in the community. At one point in time, folks were sort of eager to relegate RISC-V to a particular corner of computing, and that's not where it's going to stay by any stretch. We now see strong examples from embedded to enterprise, through various implementations and types. We saw Sci-Fi in particular come out with a PC form factor. We have others that are developing for, university levels, and then, we see those going at scale. Western Digital around storage and memory. We see NVIDIA shipping RISC-V in all of their GPUs. And we see the level of collaboration across those interests is continuing to grow.
So the way I look at this is a world where we're not going to displace ARM or x86 or even MIPS or open power architectures. I think we might end up in a world where we'll coexist happily, but I do see that RISC-V would gain the major share of the market. What are your thoughts on that?
I think that for those organizations and companies who have invested deeply in x86 and ARM, they're not going to rip and replace that. That is a really tough conversation to go have with the boss who said, well, wait a second, I gave you millions of dollars in engineers to go take this path, and now you're telling me you want to rip and replace.
Excuse me, unless you are Apple and you bring out a whole new M1 silicon on a completely new architecture. And that is certainly a possibility. So
not very many people have the pockets of Apple.
That's right. Yeah, I totally agree with you. Not everybody would be in a position. And perhaps, I'm pretty sure with the pockets of Intel and the AMDs and the like and ARM, these companies will innovate and potentially even embrace to some extent RISC-V architecture, in the sense that we might not even see them as x86 only companies anymore, or ARM-based companies. I'm speculating.
Yeah, but honestly, the needle is moving at the volume side as well. It used to be 30%, now it's growing to 40% of OEMs are designing their own silicon. And every major OEM and other cloud providers have their own internal, semiconductor arena where they're looking to optimize, especially, if you look at the white box side of things, they are looking at every aspect and feature and to sort of serve the workloads that they're looking at. So you're going to continue to see some transition, But architecture decisions are not made on the quarter or on the year. They're made for a generation of technology.
That's right.
And we see RISC-V taking a central role as those new architecture decisions are being made. Just as we once, only relied on our cell phones to make a call, and now we're eventually going to have our phones making us coffee. Those types of transitions and evolutions of technology call for new approaches. And that's where RISC-V starts to play. It's not in ripping and replacing existing products and things. It's about going forward and tackling that next level.
And I think I see that more to be a natural evolution rather than a revolution. So at that level, things would automatically flow for the right reasons, and people would be making more use of RISC-V. Let's talk about my favorite topic, which is verification. So we specialize in formal verification at Axiomise, and I've been watching the space of RISC-V, as I said, and especially the verification work going on in the ecosystem. How would we ensure that reliability of RISC-V implementations will match the quality of verification that comes from proprietary architecture-based implementations of x86 and ARM, especially, again, as you also said, with decades of experience of building custom chips and processors in all of these architectures? What are your thoughts on how the RISC-V ecosystem would cope with the verification challenges?
So I think you're seeing a lot of existing and large verification shops starting to take a hard look at RISC-V and how we can accelerate our path to getting to that level of parity. We are not taking a slow road here. We are taking a collaborative road and bringing the best minds together to tackle those challenges. And while many shops are going to take their unique approaches, you have some of the largest shops, doing a both-and approach to architectures, realizing that the growth and popularity of RISC-V is, essentially going through the roof. They see a business opportunity to bring the same level of expertise to RISC-V as they do to other architectures in the portfolio.
Yeah, I mean, I certainly see a big momentum. But what I do see as a gap is a number of, like the big companies who are building RISC-V implementations certainly know what they're doing with verification, but some of the smaller ones are still playing catch up. But again, it's a collaborative effort. So companies such as ours and Impera's and all are joining hands and helping in initiatives such as the Open Hardware, the Chips Alliance,
exactly.
and so on. So awesome stuff. Yeah, awesome. So, hey, I know you're quite busy, and I'm just looking at the clock, and we're nearly half an hour. So I would like to take the opportunity to thank you for your time today and wish you a great new year. And we'll all do more work with RISC-V. So thank you, Calista.
I can't wait to talk to you again in a year and reflect back on the progress that we made in 2021. We made incredible progress despite so many challenges in 2020. Indeed. And, the field is wide open and we're running fast.
Excellent. Thank you very much, Calista. Hey friends, I hope you liked our podcast today. Do let us know by emailing us at info@axiomise.com or subscribing to our YouTube channel. Leave your comments on the video, and we will be back shortly. Have a great, safe New Year. Thank you very much.